Welcome to the next session on graphs. What I want to do on functions, rather. What I want to do is I promised in the last section that I would do another find the equation if we're given a graph. Let us say in this case that this is what we are. Okay. Okay. Let's just change it back. Okay. And what we are given over here. Let's say this time they give us this, all right? They give us a graph and they tell us that that is at -3, and they show us the graph does something like this, and they say that point over there is -3 and 5, right? And they tell us the graph has the form y equals b to the x plus q. They say find the equation passing through, find the equation of the graph as shown passing through the point A, coordinates 3 and 5. Okay, step 1, we've identified that it's an exponential, but they gave it to us in this case, all right? The reason they're giving it is because they don't want us to write an A there. It makes it unnecessarily complicated at this stage. So what do we do? Well, first of all, can you see that they've said that this point is -3? So let's put in the coordinates of that point, and they are 0, -3. And what is that? That is an asymptote, isn't it? Can you see that? That's the asymptote. That's how we give asymptotes on a graph, isn't it? We put it as a dotted line and we label normally y equals 3. So if it's an asymptote, that means what? That means q equals -3. Therefore, we can say that y is equal to b to the x minus 3. Okay? The next thing we say, all right, is we put in what we're given. We are given the coordinates -3. Okay, we're given A is -3 and 5. So let's put them in, x and y. 5 equals b to the -3, okay, like so. All right, like so. And what do we do? That 3 goes over, it becomes 8 equals b to the -3. All right, therefore, what do? We say we prime factor this, don't we? All right. So let's have a look. We then say that that is 2 cubed is equal to b to the -3. All right. So therefore, let us now say, all right, therefore, 2 cubed equals 1 over b cubed. Okay. Equals 1 over b cubed. Let's multiply through by b cubed. Therefore, b cubed is equal to 1 over 2 to the 3, which is equal to 1 over 8. Therefore, b is equal to the cube root of 1 over 8, which is a half. Okay? All right? Therefore, that's how we found that. Okay? Let's just go through that step again. I said that b to the -3 is that. Therefore, I changed that to 1 over. Remember, if we've got exponentials, change to a positive exponent. Okay, that's why we did that. When we were doing exponential equations, we always change it to a positive. Okay, therefore, 1 over b cubed. Then what did I do? I cross multiplied, didn't I? I said that 2 cubed times b cubed is equal to 1. Therefore, b cubed is 1 over 2 cubed. Can you see how I got to that step there? All right. Then that basically allows us to write down the equation of that curve, which is then y equals b, which was a half to the power of x minus 3, or you could say that is 2 to the minus x minus 3. All right. That's how you do it for an exponential curve. The next section you're going to go on to with all of this is you're going to go on to interpretation of the graphs, right? We're going to work with given combinations of graphs and we're going to be answering questions about them. Before we go on, let's look at a few, let's just start on a new page. Okay. Let's look at a few terms. Okay. They're going to talk about, one, the average gradient. What are we talking about with an average gradient? Well, what is a gradient, right? The gradient that we know is m, right? That's a gradient, which is equal to delta y over delta x, or y2 minus y1 over x2 minus x1, correct? That is our average gradient. That is the gradient, isn't it? Now let's have a look at a straight line. Doesn't matter what it looks like. Let's just, for argument's sake, have a line that does that. Now, let's explore that line and say, right, average gradient is change in y over change in x. Okay, well, okay, here as well, there, or even there, that's delta y over delta x. And if we do this, we get m equal to delta y over delta x. And you get that m is constant. Because it's a constant slope, the gradient doesn't change on a straight line, does it? It stays constant all the way up, right? So our gradient is a constant on a straight line. That is why we use y is equal to mx plus c. And remember, just to recap, that is c over there. So what have we got? The gradient is a constant value on that line as it slopes up, or the gradient could slope down, which means it's a negative as it's sloping down. Right, next we're going to say, okay, let's have a look at it. But what about a line that curves? What about, for example, let's take a parabola, all right? Doesn't matter what you want to look like so, all right? What about the gradient of that? Let us zoom in on it. All right? How do we work out the gradient here? Well, we know the y coordinate there, but can you see the gradient depends on where you take it? Because over here, let's just draw in a line. Over there, can you see at that point, the gradient is that. But over here, the gradient is different. So because the line is sloping that way or that way, the gradient is changing all the time. Because your delta y and your delta x, look at that. Delta y, delta x, delta y, delta x. This is flatter. This is steeper. It's kind of like walking up a hillside. It's a changing slope, isn't it? If it's sort of that sort of shape, concave or convex, depending on which side you are, but it's actually that, it changes slope. As you get to the top, it flattens out, doesn't it? So the gradient is not constant on a curved line, right? Which means that on a curved line, what have we got to do? We haven't got an expression for the gradient at this stage. Later on, we're going to do it in grade 10 AP, 11 AP, grade 12, we're going to do it with calculus. We're going to find the slope at a specific point. But up until then, we've got to work with something called the average gradient. And what do we do? Well, we've got to point a curve here, let's say, and over there. And they say to us, right, let's say x is 2, and let's say y was 6. Let's say x was 6, and y was 18. Okay, that's a 6. These are, of course, the x values and the corresponding y values. Okay, they are the coordinate pairs. Okay, so if we call that x1, y1, x2, y2, okay, we now have to find the average gradient because there isn't one. Okay, the average gradient, okay, so you'd write average gradient is equal to the same formula, y2 minus y1 over x2 minus x1, which is y2 minus y1
is 6 minus 18 over 2 minus 6, which is going to be 6 minus 18 is 12 over 4. Okay, and they're both minus, so it gives me a plus 3. So the average gradient is 3, okay, between those 2 points. Right, that's how we define the average gradient. Okay, let's move on. All right, let's talk about some other terms. An increasing or a decreasing function. What do we mean by increasing or decreasing function? Essentially what we mean is we mean this. We mean that if x gets bigger then y gets bigger, we say it's increasing. If x is getting smaller and y is getting smaller, it's a decreasing function. Okay? All right? If x is increasing, x gets bigger, y gets bigger. Okay? It decreases, x gets, put the arrowhead the wrong way. If x gets bigger, y gets smaller. Let's just have a look and see what are we talking about with those two. All right? Let's once again take a simple graph. Okay? Let's take a simple graph. Can you see that graph there? Let's have a look what's happening here. All right? Let's draw it. Right? X is getting bigger. And what's happening to y? The y value is going bigger. So y is getting bigger. That graph is then increasing. All right? Now let's have a look at a graph that goes the other way around, shall we? All right? Like that. Now let's plot and see what happens. Let's do blue. Okay, x increases and y decreases. All right? So as x is increasing, y is decreasing, so we are getting a decreasing function. All right? Those are just the definitions. Well, what's happening here then? There's always an if, hey? Well, let's have a look what's happening on this side over here. Let's have a look on the green side over here first, shall we? Well, what is happening first? X is getting bigger, y is getting smaller. Therefore, the function we say is decreasing. And as we go to the other side, we always look what's happening to x. X is getting bigger, and y is also getting bigger.
So we say this function is increasing. All right? Well, that's fair enough. We've got a function that can be increasing and decreasing as it changes its curve, its shape, right? So we've got functions that are increasing and decreasing. Okay? Well, what about there's another thing that we have to talk about here, and that is a function that is in fact continuity. Let's look at the word continuity. Black. What is a continuous function? A continuous function, essentially all it is one that you can draw without taking your pencil off. So we draw without removing the pencil or the pen or whatever, okay, like that. But you know that a hyperbola, you can't, right? You can't, you have to take it off. What do we call that? We call this a discrete. A discrete function. Okay? Essentially, it's not one piece. Okay?
I know that's not technically 100%, but it's not one piece. It's discrete. You can't draw it in one go. You have to take your pencil off to draw it. Okay? That's what we're saying with that. Okay. Now, all right. What about the length of a line? Okay. Let's look at length of line. Length of a line. Well, just hold on a second. Let's just plot a point randomly in space and another point randomly in space. Okay. What is the length of the line in this direction over here? Let's just take it there, and let's take green up this way. How far is that? Well, first of all, that is going to be delta y, isn't it? And that's going to be delta, oops, sorry, let me put it into blue. Okay. This is going to be delta x, isn't it? So we're saying that's the triangle height there, isn't it? It's this. All we're doing is we're using our right angle triangles. We're saying there's point A and B, right? There's delta x, delta y, and the bottom here is delta x. So we've got that height and we've got this length. So we are splitting it up into a series of, this is all about right angled triangles and Pythagoras. Yep, this guy never goes away. All right, so what we're saying is, well, how long is that line? Let's just give this some coordinates here, just for whatever. This is, let's say, 10 and 8. All right, this point at the bottom here is, let's say, 1 and 3. Right, so if we go down here, that's 1. And if I go down vertically there, that is 10. If we go across here horizontally, that's 3. And that is 8, isn't it? Like so. So what is the length of the line? The length of the green line, the height, is there. It's 8 minus 3, there it is equal to 5. 5 units. So we say that's 5 units. And the blue? Well, the blue is 10 minus 1 is equal to 9 units. You used to doing this with working out the gradient. But all we're saying is that the length of a line, all right, on any Cartesian plane, what do we do first? We say, right, am I looking for vertical? If it's vertical, I take delta y. If I'm looking for a horizontal length, I take delta x. Okay? So vertical is delta y, horizontal is delta x. That's what I look for. Okay? In my calculations, I look for that. Okay? Let's just look at something else. All right? Well, what if they tell us, oh, one thing I need to do, always, if they don't give you, okay, centimeters or volume or time or temperature, they don't give you what the axis is measuring, in which case you use the word units. So whenever we're looking at lengths of lines, we use the word units behind it. Area, units squared. Volume, units cubed. That's what we're going to do with these. Right.
So let's have a look. What if they gave this then? Right. Let's just take, let's move you out of the way there, and let us put 2 graphs, okay? I'm just going to do a graph through here, and I'm going to do some graph going down there like that, and I'm going to give us point A over here, and that's got point B down there. Can you see?
Okay, let me label x-axis, y-axis, origin. This is, for example, f of x, and this could be g of x over here. They're just functions, right? That's all. So they've told us it's a straight line. They maybe say sketch them, and we do, and we find out where they cross the x-axis, the x-intercepts, and the y-intercepts, and we sketch the graph. Okay. Then they say to us, right, what is the length of AB? Okay, what is the length of AB? Well, let's just break it down. The length of AB is, first of all, we're looking vertical, so I'm looking at y's. So this length here is going to be y1, and this is y2. So the length of the line is going to be y1 plus y2. Agreed? y1 plus y2. Well, how do I find it? All right. Well, what I do is I know what the x value is. I know the value of x there. So I am going to substitute the x in here to find the y value, and the x there to find the y, and then I'm going to go y1 plus y2. All right. We're going to do an example in a few secs of one of these. Well, what about this side? If they did this, they said, okay, what about from C to D? Okay. Once again, the x value is given. Okay. Well, what do? We are once again, we're working with y, aren't we? So we would go, this y here is y1, and this y here is y2. Can you see, with these, don't just look for a formula, okay? Because use a little bit of logic. Once you've drawn it, you can see which graph is above the other graph, and therefore you can see which one to subtract from which one to get lengths, or to add to which one to get lengths, okay? Does that make sense? Let's just re-go over it. Once you've drawn the lines, you can see which function is there and which is there. So you can do what I did. You can say, hang on, I can work out that length and this length, and if I subtract them, I end up with what? I end up with the length that I actually want there. So in this case, y is going to be equal to y2 minus y1. Correct? Okay? Y or y1 minus y2, whichever you want to choose. Let's call that y2 and let's call that y1 over there. All right? So can you see if I take that length and subtract that, that's what I'm going to get. So in all cases here, the secret of this is to actually draw it and ask yourself the question, how do I work out the length? The same thing if you're doing horizontal lengths, right? What do? Well, on a horizontal length, we would be working with x, wouldn't we? All right. So if, for example, they want the horizontal length, say from here to here, all right, you'll be finding out what, let's change it to red, okay, you'll be finding out what that x is to there, and what that's say x2, x1. This one here then is x2 minus x1. In this, there is no substitute for actually looking at the drawing and making an informed, intelligent sort of decision about what to subtract from what. Okay? Yes, there are sort of formulas and things, but why go and learn stuff when you can actually just look at it and work it out for yourself at the end of the day, can't you? All right? So if we are looking at a few, let us draw, okay? I'm going to draw a graph here, and we're going to do a little bit of work on this graph, all right? And we're going to be here and here, all right, up to there, all right? And then this is going to come down over there. This is going to be at -3 and 3, and they tell us that that is at 9 over there. Then they tell us that there's this is f of x. And they tell us that there's another graph called g of x going through here. Okay, and g of x is like that. They tell us that's 3, and they give us a point of 1 there. And now they ask us some questions about it, right? The first thing they say, what are the equations of f of x and g of x? Okay, well, what do? We first of all say, okay, let's do f of x first. F of x, its shape is a parabola, therefore standard form. Y is equal to ax squared plus q. Have they given us q? Yes, this is the turning point, isn't it? So we've got a turning point. So what can we do? We can just fill it in. Y is equal to ax squared plus 9. That was easy. Next step, what else? Oh, they've given us these coordinates here. Write them down properly, because if you did, you'd have said that's 3 and 0 and minus 3 and 0. So you've got a coordinate, so let's try it. Let's put in x of 0 equals, a y of 0 equals a times 3 squared plus 9. So therefore, a is going to be equal to 1 in this case, okay? But it's minus because that goes across to the other side. Let me just do it in completeness, all right? Okay, that goes and becomes minus 9 equals 9a. Therefore, a is minus 1. Therefore, my equation is y is equal to minus x squared plus 9, all right? Okay, so now, okay, and let us look at the next one. They said the next one is g of x, and you can see it's a straight line, mx plus c. What have we been given? Have we been given any? Yes, we've been given c is equal to 1. We know that c equals 1. So we write there y is equal to mx plus 1. And then we just put in a point, and we know that we've got 0 equals m times minus 3 plus 1. Therefore, okay, minus 1 is equal to minus 3m. Therefore, m is equal to 1 over 3. Therefore, my equation g of x is equal to minus 1/3 x and plus 1. Plus, because a minus over there divides by a plus. Okay, I don't know why I wrote a minus over there. Let me get rid of it before I... Okie dokes. So now we've identified what that is. The next question, they say, is calculate, let's see, what do they say? Blah, 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 blah. Okay, we've got those points. Calculate the coordinates of b. All right? Okay, let me put some a's and b's on here then. All right? Calculate the coordinate of b. What is b? B is a point of intersection. How do we find out where two graphs intersect? We put them equal to each other, don't we? So we say, okie dokes, that is where f of x is equal to g of x. So we just put them equal to each other. And we've worked out f of x is minus x squared plus 9 equal to 1/3 x plus 1. And now what do? Well, basically, we can see this is a trinomial, isn't it? So it's minus x squared minus 1/3 x plus 9 minus 1 equals 0. Minus x squared minus 1/3 x plus 8 equals 0. And now what do we do next? Well, essentially, we don't remember. We don't want fractions, so we get rid of it by multiplying by 3. And what do? We go and we say 3 over 1 times 3 over 1 times 3 over 1. Remember we said we do that? That's why we do it, so that we don't forget it. Okay? Then the next step is to say, right, that becomes minus x squared minus x plus 24 equals 0. Okay? And there's a 3 in front there. Okay? What do I do now? I multiply by minus 1 to get 3x squared plus x minus 24 equals 0. We then factorize this, okay? That is 3x minus 8 and x plus 3, which gives us 3x minus 8 equals 0. Remember, we split, and x plus 3 equals 0. Therefore, x equals 3, and x equals 8 over 3.
Right? So now we know the x coordinates, don't we? We can go back. We can say, okay, hold on. I know you. Your x coordinate is 8 over 3. How do I find y? Substitute it in. Remember, if you've got an x, you can always find a y. You substitute it into the equation. Okay? So we say, right, I know that, so the equation is y is equal to 1/3 x plus 1. So it's 1/3 times x is 8 over 3 plus 1. And if you work that out, you get 17 over 9. All right? So the height is 17 over 9. All right? Let's have a look. Okay. Let's now go and put that in. So therefore, the y-coordinate is going to be, of there is x is 8 over 3, 17 over 9. Okay? Is that? That's approximately a 2. Okay? So now, what's the next thing? Calculate the length AB. I'm looking horizontal, therefore I want x coordinates. So we need to get the length of this piece and that piece. What can you tell me about coordinate A?
Coordinate A is, in effect, it's mirrored, isn't it? It's exactly the same, but on the opposite side, because y-axis is an axis of symmetry. Therefore, the coordinates over here are going to be minus 8 over 3 and 17 over 9. Okay? So what do? I've now got, I know you are minus 8 over 3 because you're symmetrical about the y-axis. My x and my minus x. Remember the two roots where it goes to ground. Okay. So how far is this? This is 8 over 3 and 8 over 3. So therefore, how long is line AB? Line AB is equal to 8 over 3 plus 8 over 3 is going to be equal to 16 over 3. And you just put that in your calculator. Depending upon how they ask it, 16 divided by 3. Okay, SD 5.3. So it comes out to be 5 1/3 or 5.33 units and units. All right. They will ask you, please read, they will ask you to how many decimal places, etc., etc., etc. All right. For example, they could have asked us the area of the rectangle that's in there, AB and CD. In other words, we'd have had a height multiplied by that. Okay? Really, they're not that difficult. We'll do another one, okay, in the next session, and then we'll carry on with analytical geometry, which is kind of the same as this, okay? So thanks for watching, and I'll see you in the next session. Cheers, bye.